um, by yours truly, but if you want to go look at it, it's on GitHub. Okay, seeing that it is 6 o'clock, I'm going to get started on the workshop. Hi everyone, welcome to Introduction to Docker. That's the workshop you're attending right now. TLDR is going to be a brief dive into what Docker is and why everyone seems to hype it up so much. A brief little thing about me, who am I? Hi, my name's Jackie. I'm currently a second-year student at UBC. In my spare time, I like to rock climb, read, and organize hackathons. And you may have actually been at one of hackathons our organization organizes, which is NW Hacks last week. But yeah, also casual socials plug. I know a lot of you guys were asking. You can follow me on GitHub, the best social media network around, or on Twitter. Okay, now let's get back onto topic. Here's a little bit about what you can kind of expect for us to cover today. So briefly, we'll do a brief introduction about what Docker is, what containers are, and why anyone in the right mind would use Docker, followed by a brief introduction into the terminology behind some of what Docker stuff is, like what are containers, images, layers, and what a Dockerfile even is. After that, we'll get a little bit more interactive and then talk about the Docker CLI, how we can actually communicate with a Docker using our command line and actually do all the steps that we listed above. And the last part of the workshop is going to be Dockerizing an actual example node application, as well as deploying that on Google Cloud Run, just so you can get an experience of fully developing to deploying. Okay, before we get started, the kind of assumption that we have going into this workshop is that you've already gone through the pre-workshop checklist. As this is an intermediate workshop, the expectations are that you are already familiar with what a CLI is. So please make sure you're kind of familiar with the basic concepts in order for you to have a good time in this workshop. First of all, please make sure you have Docker installed. This is a Docker workshop, and it is going to be pretty hands-on. If you do want to follow along, highly recommend that you have and get Docker installed. The workshop TAs can help you get that set up if you can't yourself. Second and third is know the basics of Node.js. Near the tail end of this workshop, we will be Dockerizing a Node application. So it would be nice if you know the basics of Node.js, just so I don't have to explain every step along the way. Third of all is Google Cloud CLI. We are going to be deploying our Docker container on Google Cloud afterwards. So if you have this installed, it'll make the entire process a lot easier. Supplementary resources, the GitHub repository that I've linked is a personal plug, but it is what we're going to be following along for the duration of this workshop. So if you haven't already, go clone it so you can follow along. Now to get started on the actual meat of this workshop. So what the hell is Docker? TLDR, Docker is a tool that makes it really easy to package applications into containers. Don't worry if there's a lot of jargon right now. We'll kind of work on recursively redefining these as we move along. And it comes to our second slide, what the hell a container is. So the first thing that comes to your mind when you think of container isn't necessarily Docker, right? And if you think of container, there's a lot of different types of containers in the world. You got shipping containers, you got food containers, and whatever. The whole premise of a container is that it contains things. But in the case of Docker, containers are self-sustaining in the sense that they contain everything that a container needs in order to run. So in the case of Docker and software, includes libraries, dependencies, and source code. Now, why would anyone want to ever use Docker? In fact, Docker isn't the only tool to work with containers. There's a bunch of other pieces of software like Mesos and Containerd that help you interact with containers in a very similar way to Docker. But why is Docker so popular? The first of which is it's pretty easy to get the benefits of containers when using Docker. The Docker CLI itself is decently easy to use, as we'll see later on in this workshop, and there's a lot of community support around it. So if you have any problems, you'll probably be able to find a solution to it on Stack Overflow. Second of all, Docker allows you to programmatically define containers. This means that you can write containers through code. And that means you can collaborate on containers like you would any other piece of software, like using Git and other pieces of version control as well. If all of that was a little bit confusing, don't worry. We'll be taking a closer look at some of that terminology as it applies to Docker in the next few slides. As you might have already noticed on the screen, we'll also be taking use of an IKEA analogy as well to kind of help you visualize and better understand what Docker is really doing behind the hood. You can kind of think of Docker as an IKEA store. Both Docker and IKEA put together and store packages that are fully self-contained. In the case of IKEA, it's pieces of furniture that you pick up. And in the case of Docker, it's pieces of software. So getting more into the actual Docker terminology itself, the Docker container, like I previously said, is a fully self-contained and keyword running version of your application. So relating this back to the IKEA analogy, this is when all the pieces that are once inside the box are now fully put together and assembled that can be used into a piece of furniture that can be used day to day. So this is a fully assembled piece of IKEA furniture, or a fully running and put together a piece of software as well. So this is the actual deployed version. Going a step back is Docker images. The images are templates that describe to Docker how to create a container from scratch. So this is, in the IKEA analogy, this is the actual box containing all the pieces of IKEA furniture that you have in the U-Haul, in the back of your U-Haul, and you carry back to your dorm. It's a piece of, it's like the cardboard box containing all the pieces of furniture that you pick up from IKEA itself. It has all the necessary pieces of furniture, along with the necessary tools like screws and whatnot to actually assemble it. The key part is that a Docker image contains all the pieces you need to actually assemble it and put it together. A Docker layer, on the other hand, are reusable components that can be shared across images. Docker images, much like ogres and onions, have multiple layers to them. These layers are common pieces that can be reused across different pieces of software or IKEA furniture, like a screw or a backboard or any of those like little wooden peg things that you find in every piece of IKEA furniture. You can think of that as a Docker layer. It's reusable across different types of software as well. The Dockerfile, last but not least, this is the only actual thing that you, as a developer, need to write in order to create a Docker image and a Docker container. This is the actual instruction manual that Docker uses in order to figure out how to build your image. The Dockerfile is like the manufacturer's guide. It tells IKEA how to put together the actual package itself, figuring out what materials are needed to put in each package and what order to kind of put it in. As a TLDR, if you're more of a graphical learner, this is how the kind of bits and pieces as they all fit together in order to kind of go through like a Docker workflow. So to reiterate, the Dockerfile is the actual instructions for how to build the image. This is the manufacturer's guide and what IKEA looks at to figure out how to package all of its cardboard boxes. The Docker image itself is the pre-built image that is a template for a container. In the case of the IKEA analogy, once again, this is the cardboard box that you actually pick up from IKEA and contains all the pieces you need to assemble a piece of furniture. And last but not least is the Docker container, which is a fully running version of your application, or in the IKEA analogy, a piece of assembled furniture. Okay, at this point, we're going to get a little bit more hands-on with the Docker CLI, and we're going to be assuming that you've already got Docker installed on your machine. So at this point, make sure, if you can follow along, open up your terminal of choice and run this Docker Hello World example. We're going to take a brief 5-minute break here, just so everyone can try to get to this point and see if they can get this Hello World example running. And yeah, I think TAs will also be helping out in the chat if anyone has issues getting to this start. Yeah, the question for how do I install Docker? If you go to the workshop syllabus, there is a link in the guide for how to install Docker, but let me find that link for you and then paste it. Docker has a pretty good write-up on how to do this as well. Yeah, okay, everyone's beat me to the punchline. So, question about the slide deck. This is made in Figma. There's no fancy stuff behind this. I did that manually. Favorite Linux distro? I'm a pretty vanilla man, so I'll have to say Ubuntu, but I'm actually running on a Mac right now. Nice, nice. Okay, I'm going to assume at this point that everyone kind of is at the stage. I haven't seen anyone complain about Docker installations at this point, so I'm going to go on ahead. If you do, however, have any problems, feel free to message in the chat too. First off is Docker build. You may recall that you want to be able to turn a Dockerfile, which is the manufacturer's guide, into the actual Docker images themselves. So how do you tell Docker to do that? The first of is the Docker build command. Just to quickly go over what this example is doing right here. So it's saying to Docker, hey, look in the current directory for the Dockerfile or the instructions manual for how to build a file. So that's what the dot is for. And then the -t flag tells Docker build to say, like, after I've built this image, let's add a tag to this image so we can find it more easily later on. So this tag consists of two parts. It comes with the actual name, which is the name of our image after we've done building it. So it's called node example in this case, and then colon the version. So we're just building the very latest version of this node example image. So if you've followed along so far, hopefully you'll already have cloned the Docker repository. I'm going to go ahead and open up iTerm and kind of walk you through what each of these things kind of does step by step. And hopefully this is going to be a big enough size that everyone can see this. But Docker explained to keep forgetting how I even named this folder. But now that we're in this folder, you can see that we have our node application. We also have our Dockerfile in this repository, in this local directory as well. So to execute this command, once again, what this is doing is saying, Docker, look in my current directory for a file called the Dockerfile, which is the instruction manual, and then name the resulting image, node example, and then give it the version tag of latest. So if this is the first time you've done it, it's probably going to take a little while just for Docker to install all the dependencies into your Docker container. But because I've run this a few times, it's using the cached version. But yeah, after running this command, you should be able to see that Docker successfully built this Docker image of ours and then tagged it with the name node example along with the version latest. So you may notice along the way that we have a bunch of steps that are being executed. I'll talk a little bit more about what each of these actual commands are later in the tutorial, in the workshop. But for now, just know that each of these steps is a layer that's being executed. But yeah, so now we have the Docker image. So now that we've built our actual Docker image, how do I make sure that I've actually I've actually built the image and make sure I have it on my computer? That's where the Docker image ls command comes from. It's very similar to the Linux command ls, which is, I actually don't know what it's short for, but pretty much to list stuff in your current directory. But what Docker image ls lets you do is list all the images that you've built on your local machine. If we do Docker image ls, I'm going to come up with a bunch more stuff just because I've been doing a decent amount of Docker development lately. But let me try to find it. It's in here somewhere. I probably should have cleaned this up beforehand, now that I think about it. But yeah, we have it in this list. So node example, latest, built 5 days ago, which is kind of troublesome, but it's because I have it cached. If I cleared the cache, this would say a few seconds ago, and hopefully that's what you have. And yeah, so what this does, once again, what this command does is it lists all the images that you've built so far, along with some relevant statistics or relevant details like the name, the version, the image ID, when it was created, along with this relevant size of the image as well. So now that I've built my actual image, I want to go to running my actual image and turn it into a piece of functioning furniture. So if I go ahead right now, for a little bit of context, I'm just going to quickly show you what the node example looks like if I run it from scratch. So if I go node dot in the current directory, it's basically a simple express server that just runs hello world. So if I go to localhost 3000, I get a quick hello world message, pretty nice and friendly. But yeah, I don't want to run this using Node. I want to run this using Docker. So how do I go about doing that? So you may notice right now that we can just do Docker run and then the name of the container. If I do docker run node example latest, it's going to take a few seconds, and then it's going to start up. And now I'll refresh this. Okay, I'm getting a site can't reach. Does anyone know why this is happening? What am I possibly missing here? Opening the port, yeah, exactly. So containers by default are sandboxed from the rest of your computer. So when you run a Docker container by default, its networking capabilities are not connected to your own machines. This is usually just for security case, but if we want to be able to communicate and load our Docker container stuff from our local web browser and be able to interact with it, we want to expose the port. This is pretty much just connecting our local machine's port and then forwarding it inside of our container. How we do this is using the -p flag when we use Docker run. So what this is saying is forward our local host machine port 3000 to inside of our Docker machine's port 3000. So if we kill our example really quickly, I'm going to do this really fast, but I will explain what this is in a quick second. If I run it again with port 3000, now it should work, and we should once again get a hello world message. So yeah, so by default, Docker containers are sandboxed from the rest of your computer. If you want to be able to interface with your container using any sort of networking stuff, you should be opening a port to whatever ports your Docker container needs. So Docker PS. You may notice earlier that I killed the container, right? But similarly, if you have any unresponsive processes on your current computer, you want to be able to know which ones are taking up the most resources and which ones are safe to kill, right? Normally on your computer, you would do this using the PS command, which is process status. So if I did this on my current computer, stop it really quickly, do PS. Yeah, I have a bunch of stuff running on my computer. If I wanted more detail, I would do PS AUX, and it gives me a bunch of details about what's currently running on my local machine, right? Similarly, Docker has a command that lets us figure out what containers are currently running. So if we go back and we do Docker PS, we'll notice that it'll give us a bunch of relevant details about what containers are currently running on my local machine right now. I'm going to zoom out just so the formatting is not super wonky. Yeah, so we'll have the container ID along with the actual image, along with the version, and the command it executed to start the container, when it was created, and what the current status is if it's alive. Right here, it'll also list out the relevant details about any port forwarding that's taking place. So for example, we're forwarding from our localhost machine's localhost port 3000 to our container's port 3000. So now if I no longer want to run this container, how do I kill it? Very similar to Linux, you just do docker kill, and then the container ID of the container that you want to kill. So right here, we'll notice that the ID of the container of their node example is this hash right here. So we can just copy that, paste it, and then kill it. If successful, it'll echo back to you the ID of the container that you wish to kill. So if we do docker ps again, hopefully we should see that there are no more currently running containers, and which there are none, which is wonderful. I'll zoom in again. So now at this point, you may be wondering, now that I know how to the whole lifetime of starting a container and killing a container, I want to be able to debug it sometimes, right? If I want to peek inside the container and figure out what's actually running inside of our container and figure out if any config settings are screwed up, how do I do that? Normally, if you were running on a remote machine, you would do that via SSHing into a machine. Docker containers are slightly different in the sense that Docker allows us to directly execute commands on Docker containers using this exact command right here. So I'm going to do exactly that. But first of all, I'm going to run the container once again. I just keep killing this container, don't I? But now that I have this Docker container running, I'm going to pause it, make sure it's still running, right? And then I want to run a command inside this container. So let's just say I want to execute a hello world from inside the container. What this IP flag does, so what this IP flag does is it runs the Docker container in interactive mode, which means that even after the command is successfully executed, it'll allow you to keep entering commands into it until you actually exit out of the mode. So if we copy over the container ID, once again, all we need to provide is the container ID followed by the command we want to execute. The docker exec -it, the ID of the container we want to run it from, as well as a command. So in this world, let's just say, hello, hack the north 2020 ++. And we'll get a message back from our container. If we want to, let's say, figure out what's running on our container right now, we can do ps aux, right? And similarly, if we were to run that on our own computer, this will list out all the currently running processes inside of the container. If we want to, for example, run an interactive shell to be able to debug in more detail, we can also do that by doing /bin/sh. This is the bash executable and will allow us to run pretty much what this is, like a terminal instance inside of the Docker container. So if we do that, you'll see that we have this bang, not a bang, sorry, hashtag right here. And then we will be able to see everything inside the container, and we can execute commands anyway if we were as on like a regular Linux instance, or yeah. So we do ls here, we can see that the contents of our entire Docker image listed out right here. We can once again do ps aux to list everything that's running. So right now we can see that the node application is running right now, along with our current bash command right now. If I want to leave this again, I can do exit to get out. So now I'm back on my machine. So yeah, TLDR, that is the main process of and main Docker workflow of working with Docker images, Docker containers, and whatnot. At this point, we're going to be jumping into a brief node example and just kind of get a little bit more hands-on into actually Dockerizing and writing a Dockerfile and packaging up a node application and then getting that deployed. We're going to be taking a brief, once again, a brief break just so everyone can catch up. Clone the repository if you haven't already. And yeah, if you have any questions, feel free to drop it in the chat, and TAs and myself will try to answer them to the best of our ability. Thank you, thank you. Docker running the image. Let me just go back to that. Yeah, so the Docker run command right here. Docker has pretty good documentation on all of these commands. So if you're curious about any of this, you can just look up Docker run, and it has a pretty comprehensive documentation page for it. Matthew, to answer your question, we'll only be using Node for this, but there are more examples in the repository, as you saw, for Python and Golang. Those are just different examples for what other types of applications you might be packaging. But yeah, for the sake of this workshop, we're sticking with Node. Isaac asks, why would I use Docker over something like PM2 or another process manager? I'm actually not familiar with PM2, so I'm not exactly sure what PM2 does. But yeah, I'm assuming that PM2, like its name says, manages processes. Docker itself is not a process management tool. It manages Docker containers, right? Containers once basically have the benefit of being able to package all the dependencies together, right? And you don't have to worry about running into problems where like, okay, this application works on my machine, why doesn't it work on my coworker's machine, right? Because everything is already prepackaged inside of it. There's this entire argument about Docker versus VM, but that's a story for another time. Does Docker have a process manager? I think basically you can do Docker PS, which is like close enough to a process manager as you'll get to within base Docker, but it'll basically show you all the currently running containers, which are like quote unquote processes that you can kill and manage as well. Yeah, Nick. So what would be the difference between using -p on Docker run and the expose command in a Docker file? So to my knowledge, the actual expose command inside of a Docker file doesn't actually do anything. It's more of a documentation piece than anything. Whenever you see the expose command, you still have to actually do a -p to expose the port every time. I'll get more into Dockerfile specific commands in the next part of this tutorial as well. Does Docker incur any performance-related overhead compared to running the application directly? Hongjun, yes, unfortunately, Docker containers are slightly less performant in terms of running the application directly because it is abstracting on top of your current operating system's resources, so it does have to construct like its own environment. Yeah, okay, I'm going to go and continue with the rest of this workshop. But if you do have any more questions, I think the workshop TAs will try to answer it to the best of their abilities. So first off, this is the source code. I'm going to look at this from VS Code. But here's the source code for the Express application that we were just demoing with. From a brief inspection, including looking at the package lock.json, why would anyone in their right mind want to Dockerize an application? Why would someone want to Dockerize a node application? Yeah, Drumi says, avoid package version conflicts. Yeah, that's one of the really big reasons why people use Docker, right? So people don't get into this problem of trying to wonder about, okay, which specific version of node do I need to have installed on my machine in order to run your program, right? It makes redistributing your application really easy because it packages everything you need to run it in one. Shrey Patel also says scaling. Yes, this is a really big factor. Because everything's the same, scaling up instances of Docker containers is really easy with tools like Kubernetes, and as we'll see later, cloud infrastructure providers like Google Cloud Run too. Yeah, security is also a pretty big part of it too. Unfortunately, Docker by default has some like isn't super clear about best security practices. That is like a pretty ongoing effort in trying to improve best security practices inside Docker right now. But yes, if set up really well, Docker containers are a really good way to standardize security into your application too. But yeah, you've all listed very good reasons for wanting to Dockerize this application. So it's like all run into issues where you're at a hackathon, you're building an application, you're trying to send it to your hackathon teammate, and they're saying, oh, why isn't this working? I'm getting node errors. And hopefully, if you use Docker to standardize your development environment, that never has to happen again, because the environment that you develop on hopefully is the same one as the environment that you deploy to in production as well. So let's get into the Dockerfile. We said earlier that the Dockerfile is the manufacturer's guide to tell Docker how to actually manufacture and package actual Docker image itself. So let's take a quick look at what the Dockerfile is and what it's actually doing line by line. So here is the entirety of the source code for our Docker image. And I will once again reiterate that each one of these steps is a Docker layer, right? So these are all reusable across different containers. And I'll start with the first layer. Actually, it's pretty interesting, this from command, right? What this is telling Docker is saying from official Docker, the Docker images repository, find the main node image and then use that as our base. So you may remember that Docker is based off of images. There's a bunch of reusable components. And this layer right here is one such reusable component. And it's a pretty important one because this node base image contains all of the necessary prerequisites in order to run a node application. So this comes prepackaged with npm, I think just node as well, and a bunch of other things. Yeah, 12 is just the version of node that comes installed. So if you want to find out other images, for example, you can do docker hub node, right? And then you'll see this first link right here is a detail of, hey, here's our official Docker image this contains all of the prerequisites in order to run a Node application. And here is a base image that you can use. So in order to use the base image, you can just put this from command, which base image you want, and which version tag. There's a bunch of other one of these on the internet. So say if you want to run like a TensorFlow model or like anything that requires a lot of dependencies, usually someone's built a Docker image for you. So let's say if we go to like TensorFlow, Docker hub, right here, I think. It'll give you a nice default image that has everything you need to install and run like a TensorFlow model. So you don't have to worry about installing all the necessary dependencies to run a TensorFlow model or whatever. All of these base images come prepackaged with all of the dependencies installed. And that's one really nice part about Docker. You can compose layers together like that, which gives you a lot of power. The second part is creating the app directory. So generally, you don't want to store all of your source code in the root directory. This is generally just a best practice thing. What we are doing in this step is doing two things at once. We are saying, first of all, create this /user/src/app folder if it doesn't exist already. And this is just a temporary, or not a temporary, it's like a folder that we're going to be working in for the rest of this Docker file. So it's a combination of makedir and cd. But yeah, this next part is installing the app dependencies. So what we want to do is that you may notice that in Node, we keep track of all of the dependencies that we want to use in our application through a combination of the package.json and the package.lock.json. Right? You'll notice that we pin the versions of all the modules that we're using, and that tells Node Package Manager exactly what dependencies we need. So the syntax of this copy command is TLDR, copy from my current machine's package.json. So like the current directory I'm running in, look for a file called package.json, and then copy it into the current working directory on the container. So in the case of the Docker file, because we ran workdir before, this is our current working directory, we're copying package.json into /user/src/app on the container. After we've copied over these two files, we want to tell Node to install the right dependencies based off of the dependencies that we've listed out in package lock and package.json. So this is installing all the app dependencies. After we do this, we copy over the source code and the rest of the files. So in this case, we're copying over app.js, we're copying over main.html, and we're copying over this dog image too. So we're copying everything else that we haven't copied over already into the Docker container. So this is more of an exercise for everyone else, but why are we not doing this? Why don't we just copy over everything first and then install the dependencies? Because theoretically this works too, right? We're copying over all the files and then installing the dependencies. Why is this not a good idea or not ideal? The shell doesn't actually keep the file. Not quite. The main thing is that Docker does this really nice thing called layer caching for us, which basically says that in subsequent times that we build the image, so every time we run Docker build, I'm going to check to see if any of the images have, any of the layers have been modified, right? So in this case, every time we copy over the source code, and every time the source code changes, we need to run this layer again, and then once again, install the dependencies. If the source code didn't change, then that layer is cached, and we don't have to rebuild it again. So basically, Docker says that like every time you modify a layer, all the layers that come after it need to be rebuilt. So obviously, you want to keep the things that are the most static and most expensive operations, like installing dependency, as high up in your Dockerfile as possible. So we know that in this case, if we install the dependencies first, our dependencies don't change super often, right? We change our source code a lot more frequently than we change our dependencies. So we want to actually just copy over all of our dependency-related stuff first, install that first, and then copy over our source code. That means that every time we change our source code without modifying the dependencies, all of our dependencies are actually cached for us, which means we don't have to rebuild these, which is pretty expensive every single time. So this is like a little nifty trick to just squeeze the extra little bit of speed outside of your Docker build times. Last but not least, we have this run command. What this command does is it tells Docker exactly how to start your Docker container. The Docker container itself, up until this point, is just a collection of files right now, right? So we have our source code, we have our dependencies, but we haven't told Docker how to actually start our application. That's what this command function does. And it just takes an array of things that you type into your bash terminal. So in the case of our node example, we would do node app.js, right? And we will do the equivalent of this in the actual Docker file is we split that up by actual individual strings and then put that in an array. I'm not actually quite sure why Dockerfile decided to put this as an array. I know there's certain versions of it that allow you to just put the string, but I think the most compatible version of this is to just split it up like that. If you wanted, for example, extra parameters, like you wanted to add a -v parameter for some reason, you could do -- verbose here and then run it that way. But anytime you want to add new parameters, it's just comma separated. But yeah, that's a TLDR of the base anatomy of a Docker file. There are more complex examples. For example, when you're working with more complex compiled languages like Go, for example, where you have to actual perform build steps in order to get to a binary, there is a bit more complexity when it comes to that, including optimizing like multi-stage builds and whatever. But yeah, if you are curious into diving more deeper into that, there is more resources on that inside of the Go folder if you're interested. But yeah, so now that we have this Dockerfile written out, we kind of basically have the main gist of how a Dockerfile is kind of constructed. How do we go about, now deploying this onto the internet? We've seen how to go from writing a Dockerfile and running a Docker image on our local machine, but now how do we take full advantage of a Docker container and put these out on the internet? And that's where Google Cloud Run comes in. Basically, Google Cloud Run makes it Docker makes it really easy to deploy on any cloud platform on the internet. But for the purpose of this workshop, I'm going to be using Google Cloud Run for the purpose of this workshop. I'm a bit biased just because I use Google Cloud Run for a lot of my personal projects. So that's what I'm going to be using for the purpose of this workshop. But there's a few main benefits to deploying Google Cloud Run. First of all, Google Cloud Run is super cost friendly. It gives you 2 million free accesses or invocations of your container every month, which is an absolutely ridiculous amount of free invocations. And out of all the projects I've hosted like maybe 4 or 5 of my projects on Cloud Run. I accrue maybe like a 10-cent billing cost every month, which is ridiculously low. So if you're looking for a way to host your project for really cheap, Google Cloud Run is one of the ways to go. Second of all, it's super easy to roll out new revisions using Google Cloud Builds. So Google Cloud Builds is a way to help facilitate the CI/CD workflow for deploying containers using Google Cloud Run. So Google Cloud Builds allows you to listen to a GitHub repository, so that every time you push to master, for example, it will trigger a rebuild of your container and then deploy that onto the internet, which is pretty awesome. Third of all, Google Cloud Run is highly available. Containers themselves are generally very, very lightweight. Like there is a slight overhead when you're starting applications, but it is pretty close to negligible. And containers spin up from cold start very, very easily. So this means that Google Cloud Run usually has 0 instances of your server running most of the time. But when it receives a request, it'll spin up a Docker container, serve your request, and then keep it there for around 5 minutes before spinning it back down. And that's what allows it to keep such low hosting costs, because most of the time your backend's not even actually running. But because of how highly available containers are, you can get less than 100 millisecond cold start times most of the time, which is pretty sick. Last but not least, Google Cloud Run enforces stateless backends. This is more of like a design thing than anything, but it kind of keeps with the fact that, first of all, you shouldn't be doing persistent state storage in your backend anyways. That should be the responsibility of your database, right? So most of your state should not be stored in your actual backend. Your backend should be more of an interface to actually talk to your database and communicate through there. So Google Cloud Run kind of facilitates that by making sure that your containers actually spin down after they're not active. So you can't actually store any persistent data in there. But this last point is more of a personal thing that I enjoy more than anything. Yeah, so to follow along with this step, please make sure that you've installed Google Cloud CLI. Make sure you've done this correctly. Open up your favorite terminal of choice and do gcloud. Oh, sorry, I can't even spell today. Gcloud. If you get something like this, which is basically a big help menu for Google Cloud, then you're on the right track. If you haven't already, try to get this set up so you can get a nice and functioning model of your Docker container up into the cloud. I'm going to do another 3-minute break right here just so everyone can kind of catch up and ask any more questions. But yeah, I'm going to also get some drink. Yeah, once again, if you need more help setting up Google Cloud, TAs are here to help as well. Yeah, so Shrey asks, what's the difference between Google Cloud Run and Google Kubernetes engine, I'm assuming you're asking about. So there's a difference between Docker and Kubernetes. Kubernetes is a way to allow you to orchestrate containers. So it's like managing multiple containers and how they orchestrate and connect to each other, and how they assemble to compose services and whatnot. Containers by themselves are just single running like instances of a service or whatever, right? So Google Cloud Run allows you to scale independent services really easily, but it doesn't allow you to kind of manage like a bunch of services talking to each other. And that's what Google Kubernetes engine allows you to do really easily. Are there any examples / applications of what Docker can do? There's a bunch on the internet, actually. A lot of really, you'll actually see Docker used pretty decently often in the industry, where most companies are trying to move towards standardized development environments. I also have a few personal projects done in Docker, which you can find on my GitHub. I'm avoid plugging too much right now, but I'm a big fan of using Docker to kind of standardize development as well. Okay, if there's no more issues with everyone getting Google Cloud set up, I'm going to move on and focus on showing you guys how to deploy onto Google Cloud Run. So the first thing you want to do, search up Google Cloud Run on Google. Pretty self-explanatory. Go to the first link, and then we'll go to the console. There's a pretty easy TLDR here that gives you probably a better explanation of Google Cloud Run than what I gave you, but feel free to go read that. But I'm going to go to console and set up a new project right now. So what we can do is, while this spins up, we'll select this drop-down right here, create a new project for today, and we'll call this HTN Docker Workshop. You'll see I've done this a few times already, but this is the actual workshop, so I'm going to call it Workshop, and click Create. So give this a few moments to quickly spin up really quickly. And then once this project has been created, click Select Project just to switch our context over from whatever we were previously to our project for this quick workshop. So you may recall that each running Google Cloud Run allows you to deploy and scale individual services, right? And each service is a deployment and scaling of a single container. And that's what we're going to do right now. So we're going to create a new service by clicking this Create Service button right now. I'm going to zoom in a little bit. Hopefully this will help. Create service. And then it's going to take a few minutes just to enable our Cloud Run API. But in the meanwhile, while we set this up, we also want to set up something called Google Container Registry. So Google Cloud Run is a little bit finicky in the sense that it refuses to pull from Docker Hub. It wants you to use their proprietary thing called Google Container Registry, which is basically Docker Hub So you can think about it like a GitHub repository for your Docker containers, Docker images, sorry, but Google based. So if we go to container registry, we'll open this in a new tab. So while this is being set up, we'll quickly briefly explain what Google Container Registry is. So like I said, it's pretty much a GitHub repository, but for your Docker images. You may remember that on our localhost, we have a list of these images that Docker image ls. We have a list of images on our local computer, right? But like the difference between Git and GitHub, one is local on your machine and one is a cloud provider that kind of manages an archive of all of those for you, right? Similarly, we want to be able to push our stuff locally from our computer up into the cloud and into Google Container Registry. So if you have Google Cloud set up already, Google Cloud should manage all of your Docker credentials for you so that pushing to Google Container Registry is pretty painless. So the first thing we want to do is actually tag our image so that it has the right format. So if you want to know what the exact format is, it is at the bottom of the README. I'm just going to actually read this just to make sure I don't screw this up too. But if you go to the very bottom, to tag the image and deploy it and push it to the cloud, we'll follow this format. So what we'll do is Docker tag, which tags an existing image and adds a new tag to it. Docker tag with the local image name, along with this format that Google Cloud Run expects. Google Container Registry, sorry. They both have the same acronym, unfortunately, but we'll do gcr.io, which is the domain that Google Container Registry uses, / the name of our project. In this case, it's whatever is the name of the project that we created right here. So it's name in this dropdown. And then the image name, so we can name this whatever along with the version. Right? So if we do that, we can do Docker tag. So we'll do node example latest, right? So we'll tag the one that we built a few minutes ago. Tag it gcr.io / htn docker workshop. You might have named this differently, so put in whatever name you put in previously. And then / node example, and then once again latest. And then hopefully that'll have tagged correctly. So then if we do Docker image ls again, hopefully we'll see that we have one that was tagged a few seconds ago. So this one right here, googlecloudrun.io / htn docker workshop / node example. That's the one we just tagged. So if we want to push this up into the cloud, well, it's similar to git push. We can just do Docker push, and then the image that we just built, gcr.io / htn. I'm lazy, so I'm just not going to type out the full thing. Autocomplete that node example, and then the version, which is latest. So by executing this command, this will tell our local Docker to gather all of our images, gather the image that we specified, get all of its layers, and push the layers to Google Container Registry. Sorry. But yeah, so meanwhile, it's just uploading all of our files. You may notice that we have a bunch of layer already exists, which is really nice. This is actually from the node example, the node base image. Because Docker Hub kind of keeps track of all of those together, it actually doesn't need to repush images that layers that exist already, right? If it's a common component, right, like a IKEA like screw thing, we already know how to build those, right? We don't have to rebuild it every time someone uploads us a new version of that image because we know it already exists. So Docker's pretty smart in that way and allows you to cache and memorize what layers it already knows about, which is really nice. So after we push that, we should be able to refresh our repositories and notice that, awesome, like we pushed up our node example image and we can see it running right over here. Now that we have this repository set up, we can go back to Google Cloud Run. This is actually being done, I think, right? So I'm just going to refresh the page just to make sure. But refresh the page. Hopefully, it'll show us that Google Cloud Run is successfully set up. Then we can pick a region. Generally, US Central is pretty good. It's just pretty self-explanatory.
Nice.
It provides you the pretty good availability across the entire North America region. If you're in a different part of the world and watching, hello, you can select a region that best suits wherever you're currently located. Service name, it doesn't really matter what you call this, but I'm going to name this the same way as I did before. I'm going to call it node example. And then once you've done that, we can configure the service's first revision. So remember that we uploaded our image to Google Container Registry. We can once again select that image by clicking select here, open up a nice menu on the side here, and then we can select the one that we just uploaded, which is this latest one, which is uploaded 1 minute ago. So we select that, and then click next. If I go back, actually, you may notice that there's an option to continuously deploy new revisions from source repository. So this is the Google Cloud builds I was talking about. This allows you to listen to a GitHub repository and kind of automate this entire process. But for the sake of simplifying this workshop, I'm going to just deploy using Google Container Registry. So we'll click next, and then we'll get into settings about how each of these are triggered. So ingress pretty much is a fancy networking term for incoming traffic. We don't have to worry too much about this because we're just developing an external facing API right now. So we're just going to allow all traffic to our endpoint. Second of all, we want to talk about authentication. Do we want people to authenticate when they try to hit our website? In the case of Node and Express applications, you probably don't need to do that unless you're doing something that requires authentication, in which case you can figure that out on your own. But for now, we are going to allow unauthenticated notifications for now. And we'll click create. And now we play the waiting game. And while we wait for Google Cloud Run to provision our service for us, and as soon as it's done, we'll have a URL that we can visit. And I'll share with all of you so you can visit too, just to make sure I'm not fluking this entire presentation. Oh, it looks like there's a bunch of people from all over. Hello from Ghana. Wow, nice. People from all over the place. From Saudi too. Yeah, so now that we have all these check marks and happy green check marks everywhere, we know that our service is healthy and ready to go. So what we can do is visit this URL, and lo and behold, we have a hello world. And this is accessible by anyone on the internet. So if I send you this link in the URL, I'll send it right now. Everyone can go and hit that URL and see a hello world that we just deployed, which is pretty sick. This allows you to get up and running with APIs and whatever and whatnot really quickly without having to worry about provisioning like Heroku, keeping a Heroku dyno alive, setting up ngrok, and a bunch of other hacky stuff that people usually do for hackathons. Google Cloud Run is usually a pretty good way to do it too. But yeah, that concludes pretty much the entire deployment process. Throughout this entire workshop, we've kind of covered what it means to go from writing a Dockerfile to running that Docker container locally on your own machine, as well as deploying that container all the way up until the internet, until everyone can see it. We've also kind of talked about what the Docker terminology is, as well as a basic workflow of kind of how to work through Docker stuff. But yeah, that's pretty much brings us to the end of this workshop. Thank you everyone for coming today. I hope you learned a thing or two about Docker and found something you can apply to your hack, and maybe convince you to use Docker more in your personal projects too. Best of luck and happy hacking, everyone. And another social plug for everyone who doesn't follow me already. And yeah, I will be sticking around for another 7 minutes just to answer questions, as well. If there's any more questions anyone has after the workshop as well, it's going to be on Discord in the backend channel. I will be watching that while I eat dinner. So. Quick question, is there any way we can use our own domain name instead of using the Google Cloud given domain? Absolutely, yeah. So I host the backend for one of my pastebin clone I made. So the backend for this application is actually hosted on Google Cloud Run. And it uses the prefix api.controlv.app. And Google Cloud Platform makes this actually really easy to set up. So if we go back one step, there's a way to manage custom domains, right? So you select your service, you can click Manage Custom Domains right here. And if you've already sorry, if you've already registered your domain with Google, you can actually add it really easily. So you can just click register domain. And then hopefully any, okay, I don't have a setup for this project yet, but the main process right there is you can click manage domains and then set it up really easily. I'm going to go to Control V just to show you what it looks like really quickly. I think if it will let me go back. But yeah, so I have a domain mapping for this api.controlv.app, and it just redirects everything there. Ritvit asks, how difficult is it to learn Docker Compose if you've already learned Docker? I would say it's a decent step up. There's a few new concepts in Docker Compose that are completely new to Docker, for example, like persistent volumes and networking between containers that you have to learn to manage. But there are a decent amount of guides for those on the internet as well. You can find a few more resources for learning Docker Compose at the bottom of the Docker Explained repository too. Angel Shah, can you use this to host a website, both front-end and back-end? Technically, yes. Although I think there are better solutions to host front-end, just because Google Cloud Run does charge you after like 2 million invocations. And there are services that allow you to do free hosting for front-end applications, like GitHub, for example. Usually, I just use Google Cloud Run to host back-end related things. Yes, convert to Google Cloud Platform instead of AWS. I saw that there are operating system images on Docker. Do they allow, say, running Linux command line applications on Windows or vice versa? Yes, actually. So you may have noticed that you can go to Docker Hub Linux, for example. This will allow you to basically have a mini Ubuntu or Linux instance. Oh, sorry, go to Ubuntu one. You can have an entire Ubuntu operating system on your computer pretty much, and then run the same things that Ubuntu runs. It's not ideal for running applications day to day because it is pretty difficult to get GUI related stuff. For example, like any application that requires opening like a window, for example, it's not super great for Docker. Yeah, as Haoming said, your probably best bet is to use WSL at that point. Does it work like Cygwin or is it hypervisor? So I do believe Docker is based off of the hypervisor, especially specifically the Hyper-V protocol, if I'm not mistaken. So yeah, it is a hypervisor. Okay, I'm probably going to call a workshop there then, seeing as most people have already left. But for the people that are still here, thank you once again very much for coming. And I hope you learn lots. See y'all around and best of luck in your hacking. Bye, everyone.